see what we get. Oh, that didn't sound good. Hello everyone and welcome back to the restoration series on the Telefunken Gavotte, the rather large transistor radio from the end of the 60s. In the previous video I showed you that I had quite a bit of distortion or noise coming through the speaker, and it's still the case. See? Can you hear that? No, this sounds like it's bad reception or that there's an antenna issue or something like that, but that's not the case because at the moment the radio is on the pickup input. And also this, okay, so this is the, I think this is the treble control, bass control, volume control. See, this is the volume control, and it's not really influencing this noise that is coming through. So this means that according to me, the issue will be in the power supply or in the amplifier. So I started with the power supply. As usual, you should always start with the power supply. And the power supply here on this radio is quite basic. You just have the transformer here. The power transformer. You have two secondary windings, one for the lamps, the dial lamps, and then the other one which is going through a bridge rectifier, and then which is filtered, and you have some resistors, and that's it basically. So it's really simple. I checked everything over here, and according to me everything is still fine. The voltages are a tad low, but not drastically low. This capacitor over here, this filter capacitor, it's a 2500 microfarad capacitor. So that got replaced, even though according to me it's not really necessary. So if I measure this capacitor, let's see what we get. See, so we have 2700 microfarad, it should be at 2500, so that's okay. ESR is very low, so that's good actually. And then I also measured the leakage, and the leakage was also pretty good. It was almost as good as a brand new one, the brand new one that I now put in place there. But hey, since I was in there anyway and I had the cap out of the radio, I decided not to put it back in anymore. It's almost 60-year-old cap. So it's from 1970, so that's 53 years old. So yeah, I decided just to put a new electrolytic in there. So according to me, the power supply should be fine. So our issue, I think, will be in the amplifier. Now here we have the amplifier section. So we have the output transformer, and then here against the heatsink here on the outside of the radio we have the output transistor. See, over there. And on the schematic that looks like this. So here we have our output transistor. It's marked here as an AD150, but in the radio we've got an AD149. Now I don't know what the differences are between these two, I'd have to look it up. Then we've got some preamp resistors, transistors over here. Here we've got the output transformer, but what immediately catches my attention here, and yours as well, is these two electrolytics over here. So we have 2500 microfarad and here also a 2500 microfarad. So this electrolytic over here, that's the one on the emitter of the output transistor. That's this guy over here. Now, there is something interesting about this one. Let me just lift one leg out of circuit here. See, this solder tab here broke off while I was desoldering it earlier. I'll have to pay attention to that a bit more, because in the power supply there is also a solder tag that broke off. So these things, they seem to be pretty fragile. So I'll have to be a bit more careful there. Let me show you what happens here when we measure this guy. So this is the electrolytic on the emitter of the output transistor. And it should be a 2500 microfarad at 10 volt. Yeah, 3750, that's no good. So this one really has got to go. Okay, so this one is out. That's one for the casualty list. There is a new one. And let's see if we have already maybe an improvement. And the answer is clearly no. Okay, let's continue the hunt. Okay, so the second one, and that's this guy over here. That's the big one all the way down at the bottom. Now, how the hell am I going to get to there? I think that this entire section can come out, or at least can swing out, because yeah, I also in some way or another need to be able to check this PCB or get to this PCB, because that's the amplifier PCB. There are some transistors and some electrolytics on there as well. So that's basically, yeah, this entire section over here, or most of the section over here, is all located on that PCB. So I would like to get to that anyway, and like this is not gonna work. So I believe that if I loosen two screws over here to detach this from the chassis, and then if I loosen 3 screws here from the bottom, so you have 2 on this side and 1 there in the middle, that this entire section should swing out. So I am not sure, but let's try it anyway, because otherwise there is no way that I'm gonna get to that capacitor and to that PCB. Okay, so before I'm continuing with swapping out capacitors, I'm just trying to debug some things here. So I have the scope now connected to the base of the output transistor. So that's over here. And then you see that yeah, the noise is clearly already there. So it has to be somewhere before the base of the output transistor. Now I have the scope inverted here because I haven't mentioned this yet, but this is a positive chassis circuit. So that means that the positive side from the rectifier here is connected to the chassis, and the negative side is connected, yeah, into the circuit. So as you'll see, all the electrolytics here, they are, yeah, the other way around. For example, the negative side is connected to the emitter of the output transistor, and the positive side is connected to chassis. And now the problem here a bit is that it's quite difficult to, yeah, probe this circuit a bit further, because the PCB there is quite hard to reach. I can, however, check here on the input of the amplifier PCB. So the signal comes from the radio section, the tuner, then goes to this small board over here, that's the tone control. So you have the volume, the treble and the bass controls, and then via this wire over here, or this cable, it comes to the amplifier board, and this is the input here to the amplifier board. And if I show that on the scope, see, so there is basically nothing on there. Well, at least the distortion isn't there. So I believe that it's somewhere in the amplifier circuit. So if we go one transistor back, so if we go to the base here of the AC117, then see, I can clearly still see something there. So let me see if I can go even one further back, that's the AC122. That base, where is it? That should be over there. See, over there, I can't really see. Yeah, maybe the signal is so small that I can't see it, but so these small screws which are holding this entire section together here, they are quite annoying. These are hexagonal screws, and I had to search quite a bit to find a tool that fits this, but apparently they are 5.5 millimeters. So if you have like a 5 millimeter tool, will be too small, and a 6 millimeter will be too big. So 5.5. Yeah, I can feel it's coming loose, but let's just be very careful here. Ah, okay, so here you only need to disconnect this screw over here. The bottom one on the heat shrink not, because that is bolted to the plate that we are loosening now from the bottom. So from the bottom there are 3, and here on the top on the heat shrink. And now this entire section here is loose, but I'm not sure will I be able to move it out or lift it out. Yes. And now I can reach both this electrolytic. Wow, it's completely in the edge of the frame here. So yeah, now you see I can at least reach this electrolytic and swap it, and then I can also reach everything here on this PCB. And as you see, there are quite a bit of electrolytics here. Let me zoom in a bit. See, so this is a transistor, and here we have another transistor. Yeah, you can see that one, but there is 1, 2, 3, 4 electrolytics, and yeah. So I've got some things to do. I've got some things to check. I'm definitely gonna swap this one, no matter what what it reads. Okay, so have a look at this one. This is a 47 microfarad at 6.3 volts. It's measuring 126. And this was, just for reference, C304. And C304 is the 47 or the 50 in this case microfarad capacitor on the emitter of the first of the 3 transistors. So we'll definitely going to change that one. And as you see here, so here you have a potentiometer. It's the R304. And that one is used to adjust the quiescent current of the output transistor. But as you see, this guy over here, it's really, I mean, it's also on the emitter of this transistor. So there is another one, another 47 microfarad capacitor. I think it's that guy over there. That also is measuring quite high with the capacitor tester over here. So yeah, I really think I need to go through the entire board here and check just every single component, I guess. Okay, so I now completely disconnected the tone control board from the amplifier board, and so there is no input anymore going to the amplifier board at all now, and still we got the noise. So yeah, now it's really clear that it's coming from the amplifier board. Okay, so at least we know that for sure. And also I think I can now work a bit better on this. Yeah, now it opens up completely. So okay. Okay, so the amplifier board has been completely recapped and the noise is still there. See? Now, if I connect a signal to the input of the board, So here is normally the output from the tone control board, and then it goes to the amplifier board. Now if I put a signal on there, then it almost totally drowns out the noise. So if I put, for example, 400 Hertz on there, amplitude 50 millivolt peak to peak, so that's a very low signal. See, so it completely drowns out the noise. But if I decrease the signal strength to like very low, 5 millivolt peak to peak, I think I can still hear some noise in there. And also if I increase the volume or the sound level, there it starts clipping. So it starts clipping at about 170 millivolt peak to peak, which to me sounds a bit early, especially if you think that the line level is 1 volt or so. So I don't know. I think we have a noisy transistor here, and I'm suspecting this one, the AC122. What I don't know if this noise level is normal or not. I don't think it is, because I can't imagine that the radio would be this noisy when there is nothing basically connected to it. So that's here, this guy, that's the AC122. It's basically the first transistor which, yeah, the signal path encounters on the amp board. Now let me show you something. This is free spray, and listen what happens when I put some free spray on this transistor. So I'm just gonna put the microphone now to the speaker so that you can hear the noise better. Hear that? Completely gone, the noise. So as you notice, when I put free spray on the transistor, it completely drowns out the noise, or it completely removes the noise, and the transistor is still working, because see, if I put my signal on there, I still get it coming through. So the circuit is still working, but the noise of the transistor is totally gone. And when I let it warm up again, or when it comes to room temperature again, then the noise is coming back. So I do believe that, see, I can already hear it coming back. I do believe that that this guy here is causing the issue that we're having with noise. So I pulled the transistor, burnt my finger in the process, but yeah, shit happens. See, here it is. And now the noise is just completely gone. So I'm gonna try to find a replacement for this guy. See, this is an come on, focus. See, this is an AC122. Finally, they have finally arrived, my replacement transistors. So I ordered some replacement for the AC122. I ordered a bit more than I actually needed, just to have some spares and to be sure that I got a good one. But yeah, it took them 2 weeks to arrive, of which 1.5 they were stuck in customs here in Belgium. Yeah, it has really become a pain to order stuff outside the EU recently. In the last couple of years, it has become very unreliable, unpredictable on how much time it will take to arrive, how much it will cost to arrive. You don't know anymore up front. But luckily there was no additional cost, but it took quite long. Now this is also the reason why it took me so long to put out this video, because I wanted to fix this issue with the amp really still in this video. I really wanted to diagnose the problem and fix it in one video, so that it would also be easier for you to follow, and also because I didn't want to make this restoration into a 25 part series. I just wanted to, make it a bit more consistent. Now, in the meantime, I haven't been sitting still. I recapped almost all of the radio, all the electrolytics. Almost all of the electrolytics were recapped. I'll come back to that later. And I also managed to really, now I'm like 99.9% sure that this transistor, the original AC 132, is bad. And I'm gonna show you actually how bad it really is. Okay, so what I got here is a small little circuit which I built, and the idea comes from an article which I found online, written by R.G. Keen, and it's a quite well-known method of testing germanium transistors. There are lots of people interested into germaniums who use this as a reference. Most of the interest in germaniums these days are in the community of guitar pedal builders, and so this is really aimed at testing germanium transistors for use in a guitar pedal, but obviously we can also use it to test germaniums for a radio. So it's really simple. What it does is the only thing, so I have the transistor over here in the socket, and at the moment in this configuration the base is left unconnected, so it's floating, so there is no base current. And then you have a 9 volt applied here between emitter and collector, and there is a resistor on the emitter, and that resistor is exactly 2.472K. They say you should pick a resistor that is as close to that value as possible, but I just took a 10 wound potentiometer, which is much more easy to set it to exactly 2.472K. I can show the circuit here on the screen. It's really very simple. Now what we're doing here is we're measuring across that resistor, so across the 2.47 resistor, and that's the voltage that we're measuring across that one. So this is an indication for the current, and since the base is left unconnected, this is pure leakage that you're seeing here right now. And you notice that while I'm talking, this has been creeping up quite drastically. So and you also see that it's fluctuating, which is also not a good sign. We can test a new or a new old stock transistor later, or a good one, but this is the one that comes out of the radio, and you see that it stays creeping up. So if I do, let's say 2.8 volts, and I divide it by it's now over 3 volts, but let's take 2.8, and I divide it by the 2.472, then I get the leakage current in milliamp, and that's in this case 1.13, and it's already still going up, you see. So that is insane. The amount of leakage here is really, really high. For germanium always has leakage, but this is like 4 or 5 times as much as it normally should be. So this is just, that really is a big sign that the transistor is faulty. And also that it's moving around like this all the time. That's also not a good sign. Normally it should stay relatively stable, but here this is jumping all over the place. So what else does this circuit do if you push this button? Then it switches this 2.2 mega ohm resistor between the base and ground. So then you're gonna get some base current, and then you can measure the amplification factor of the transistor. So let's do this. and you see that it jumps up to 4 volt from 3.3 to about 4.1. Now, because it's jumping all over the place, it's still rather difficult to know exactly what is the gain here. Now, the cool thing about these two resistors being as close as possible to their two values, so 2.2 meg and 2.472K, is that the reading that you get here, so if you notice how much the voltage increases when you press the button, then the increase in the reading here is also the gain. And that is really a nice, that's really the reason why these values of these resistors are chosen here, that you can really easily read the gain. So let's say that, but it keeps creeping up here, it's really crazy. Now, if I push this button, normally you should let it stabilize for quite a while, but this transistor is never gonna stabilize, it keeps fluctuating all over the place. We are already at 5 volts, which is insane, but okay, let's say 4.9, and we're gonna subtract from that 4.2, so we have here 0.7, so that means we have a gain of 70, more or less. So that's the reason why these values are chosen, so that you can just push this button and you can easily read from your multimeter the gain that the transistor is giving. Now let's turn this off, because it's quite impressive the amount of leakage that this transistor has. And let's put in a new one. Okay, that one's in, and let's hit it with 9 volt. There we go. We can leave it stabilize for a bit, but you can already see that it's much more stable. If we look here at the leakage, so we have 0.691, and if we divide it by 2.472, we have a leakage current of 280 milliamp, which is in the range what you would expect for a germanium transistor. Below 300 is what you should normally, if you go above 300, then you might start wondering if it's a good one or not. Let's check the gain. Obviously, it's better that you leave this stabilize for like 5 minutes or so. Same thing with the gain. Maybe I should switch this button to an actual switch, so that I can then enable it and let it stabilize for a while. But let's see what we get. So we have 1.81. Yeah, it's creeping up a bit. Yeah, 1.822 minus 685, 0.685. So we have a gain of 113, which is quite a lot actually. Now, if you look at these transistors here, then you'll see that they are marked with a dot. So let me just show you. See, so here we have so TFK means Telefunken, AC 122, and here you see there is a green dot on there. And this green dot signifies two things. First of all, it marks the collector, and second of all, it gives an indication on the gain of the transistor, the expected gain. So when these transistors were manufactured, they were classified into different categories of different gain categories, and every category got his identification color dot. So green, if you look at the datasheet of Telefunken, means somewhere around, so between 85 and 140. So that means that we are more or less, we are in the range here. So this transistor here is performing as expected. We can test a couple more to see if we get a better one, but hey, I think the one that we got here is already quite good. It's stable and it's having quite a nice gain. So that's already fine. Now the one that I was in here, I don't actually know which manufacturer it was. It came out of a Telefunken radio, so I would think Telefunken, but I'm not sure. The collector here is marked with an arrow, see, or a triangle pointing down, and it's also marked with GR. Now, if you look up GR in the transistor equivalent sheets, then they say that GR means gray. So that means that that should be like a gray dot, but yeah, there is no gray gain category for this type of transistor, so I think it means green, but I'm not sure. So yeah, I bought the ones with a green dot. They are let's say in mid-range gain category, so I guess this should be fine. Anyway, we have a potentiometer on the emitter of this transistor to control the current, collector current. So yeah, I think it should be fine. Now, before we continue with the transistor swap and trying to fix that issue, I'm just going to show you what I did on the rest of the radio. So first of all, I cleaned the insides here already a bit better. I did a full recap of all the electrolytics, apart from a couple, but I will come to that. So see, here is one, there is one, there are some smaller ones over there. The amplifier board was completely recapped. So all the caps here have been replaced. And then we have the tone control board. See, so over here is the tone control board. You have the 3 potentiometers for treble, bass, and volume. And there were also some electrolytics on there, so they have also been replaced. And that's how it looks on my nice schematic. I printed out a schematic on 3 sheets of A4, so it's a huge one. See all the capacitors marked in pink here, they are all replaced. Here there are also a couple which are replaced. And then we have a bit of an issue. See, this section over here, that's the IF section. This is all located in the IF can. So you see the dotted line here marked with ZF201 is inside the IF can. And we have also a couple of electrolytics inside here. So see, there is one. I think there are 3 in total. See, here is another one. And then the third one, can't find it right now. Yeah, there it is. Okay, so these also have to be replaced. And that's that can over here, the big one. Now, the problem with this one is you cannot lift the shield off because you can impossibly reach the screws like this. So there are 2 screws here on this side, but even worse, there are 2 screws on that side, and it's impossible to reach them. So you need to desolder the entire the entire can from the bottom of the PCB, and I already did that. So it comes out now, but it took a while to get it desoldered. So you have all these pins that you need to desolder from the PCB, and then take it out carefully. We have this insulator piece of, I don't know what it is, mylar or something. Just gonna take that off and put it aside. And then you can open this thing up quite easily. And see, it's quite cramped in here. And there, indeed, we have the electrolytics that still need to be replaced. So this is, everything you see here is IF stage. So here you have 1, 2, 3 electrolytics. And I measured them, and they are not horrible, but they are quite well out of spec. So I'm definitely going to replace those. Now the problem is also, this is also a PCB, and they are soldered on here via the bottom, I guess. So this also needs to come out in some way. Just still need to figure out how. But anyway, you can see, even if you would be able to get the cap off on top, you can't really access the solder points here for these caps, so you still need to take out the entire can. Okay, let's see if we can get this out and how we can get it out. Is there something soldered here? Is this soldered? Yeah, it could be that the PCB here is soldered to this shield. So I think you're gonna need to remove that as well. Okay, let's see if we can get this out. Now, there is a second problem here, and that is I have been now changing quite a bit of things, and yeah, changing capacitors, and now I'm also going to do the caps in this tuning can without testing the radio and seeing if everything is still working, because I didn't have the AC the amplifier was basically not working. So what now if one of the transistors here in this can is also bad? Honestly, there is no way to test this if this can is working correctly outside the radio. So I would need to put it back, and you see how involved it is to even get it out. So that means that if I now just only swap the caps and don't test anything else, then I'm gonna put it back and maybe find out that there is a transistor in there which is not working as it should, and then I need to take it out again, and it's gonna be, yeah, very quite a bit of work to do it like that. So I would like to have a way to test everything on here, on this entire can, before putting it back in the cabinet or putting it back on the chassis. This one is almost loose, I think. I have to say that this part is not that easy to repair. I thought that when I was starting to work on this radio, like, oh, it's just a simple transistor radio, a big one, so there will be a lot of space in there, and there are not going to be a lot of components relatively, and everything is going to be easily accessible, but not really. I think they are loose. It took me a while to get them loose because, yeah, this shield is dissipating so much heat. But then I brought in the big desoldering pump, and this one is, yeah, they are really difficult to get loose. But I think I now got it. Yeah, that pin is definitely loose, but this one here, I don't think it is. Ah, yes it is. Okay. Wow, nice. Okay, so we've got 3 caps here. So these are both 10 microfarads at 10 volts. This is a 4.7 at, I don't know, something similar, I guess. I think 25, doesn't really matter. I'm gonna start with these two here. Now, I'm not that good at solder and chat. I'm not as good as X-Ray Tony B at solder and chat, but I'm gonna do one anyway. So let's see how easily it comes out. I don't know. I haven't yet worked on a PCB like this. It does seem to be rather fragile because it easily bends. So be careful. I'm gonna start with this guy. Let's see. I don't have my temperature set too high because I don't know what it will do to these traces here. Okay. I think I need to lock this because it keeps twisting. Okay. And maybe I'm just being overly careful here right now, but okay, that one is loose. Yeah, I know lots of people don't like these soldering pumps, but I find them quite acceptable. If you have a thing to desolder that takes heat easily, like these types of PCBs, then they are quite okay. But this one is loose, I could just pull it out. But let's wait. Let's see, where is the minus is here on the edge. It's for both of them actually. That's the negative side, is on the edge of the PCB. So I think I can just grab it. Yeah, there we have it. Okay, let's give it a test and see what it says. So this is a 10 microfarad. The leads are really short. Yeah, 12.4 is still acceptable. ESR of 4 ohms is not great. But yeah, since we're in here, we're gonna swap them anyway. Let me just clean up these solder pads here. I have to say, it's already quite small for a PCB of this age. This, I think at that time, this would have been really miniature. Let's put in the new one. Yeah, you see, I'm not that great at soldering, chat. I don't know what to tell here. Just that, yeah, the traces, they do seem to be holding up quite well. It was the same on the other PCBs. They don't lift, they don't, yeah, they don't break off. They are quite sturdy. So it is possible to replace these components quite easily. Snap them off. So that one is done. Next one. So that's what I'm gonna leave it at for the solder and chat. I'm just gonna do these other two and I will get back to you when I'm done. Alright, these have been done. This one was actually a bit worse. It was about 15 microfarads instead of 10. And this guy here was measuring about 6.5 instead of 4.7. So they have been swapped. Before you start complaining like, hey, you're swapping them out with cheapo Tiapo caps. First of all, Tiapo isn't that bad. And second of all, they are 105 degrees caps, so they aren't the worst. And also it was the only thing I had in stock, so it was that or nothing. This one is the most critical one, basically. That's the electrolytic on the detector, the FM detector, and that one I swapped with a high-end Panasonic. So that one should definitely be fine. Now, what I'm gonna do here with this, because I think I'm now gonna continue and check all the components on here to see if everything is fine, if there are no resistors out of spec and these kind of things, because I really want to know if this board is good before I put it back in the can, and because it's so much work to solder back all these pins, and if then there is still something wrong, and then I need to take it all out again. So I'm just gonna go through the entire board here. It's gonna take a bit of time, but yeah, I think I'll save a lot of time in the long run if there turns out to be that there is one resistor bad or something, or one resistor open or something like that. So yeah, it's gonna take a while, but it's gotta get done, right? Yes, so I checked all resistors that I could, and they all seem fine. All the coils are also, yeah, show continuity, so that's also fine, I guess. I haven't found any big issues with this. Now, the thing is these two transistors here, and I think I'm going to pull them out and test them, because I don't want to put this back and then have to conclude that one of the transistors is bad, and then have to take everything apart again. So I think it's best to just pull them out, test them, and then if they're okay, put them back. So I've got the AF121 in my little makeshift tester here. Let's enable the power. See, and we've got a very small amount of leakage, so that's rather good, actually. Let's see what the gain is that we get. So 227 minus 4.5. So that means we have a gain of 22, a bit above 22. Yeah, more or less. So that's not fantastic, but I guess that's sufficient for an AF121. It's quite difficult to find characteristics on these transistors, yeah, in the amount of gain, because that's not really, they're not high gain devices. But I found on some places like a gain of 30, so I guess 23, 24. See, it's still rising a bit, is okay for a transistor like this. And obviously it still works with low leakage, so that's fine. I'm gonna put it back and we're gonna test the second one. Now this is interesting. This is the AF137 in the tester now. And I got a leakage of 0.6 volts, so that's about 250 microamps, which is okay. It's definitely noticeable on the meter here, but I guess it's still fine. Now, watch what happens when I push this. Okay, so we are at a gain of 4 volts, so that's a gain of 400. Is this even possible? Wow. That's quite insane, actually. The amount of gain that we have here on this transistor. So, I don't know if it's supposed to be like this, but this is incredibly high gain. See, it's 400, the gain, more or less. So, yeah, if I check the data sheets, they don't really specify a maximum gain. They say like minimum of 80 or something, or I don't know, minimum of 60. But 400 is really off the charts. But hey, yeah, that means that the transistor is definitely working. So I'm also gonna put it back, and then I guess we can close it up again and put it back into the chassis. Okay, so I have everything ready to do a test again. Exciting because I haven't powered it up in a couple of weeks, and I hope that I haven't broken anything. So I replaced the transistor here in the amp. For the rest, I haven't put the IF can back yet because I have the amp completely disconnected from the rest of the yeah, the radio at the moment. I'm just feeding in here in audio signal with the signal generator directly into the amp. So I'm even not using the tone and volume control board. So first I'm gonna see if I didn't create any shorts and if yeah, we get some sound out of it and if the noise that we had is now finally gone. So the radio is turned on and I have the dim bulb here, only a 15-watt bulb at the moment. So let's see what we get. Oh, that didn't sound good. That really didn't sound good. That doesn't sound good at all. Let me just check if I've done everything correctly here and if I'm not shorting anything out here, because that doesn't sound good. Yeah, okay, so I guess it's probably because the input is floating, because see, if I enable a signal on the signal generator, then it's actually working quite well. I'm only at 20 millivolts peak to peak here, and I'm at 175 volts. If I give it another bulb, I'm now at 225 volts, which is what it should be, more or less. And if I increase the input here, that is working quite well, but yeah, this is scary, this sound. I'm just gonna hook up the tone and volume control board again and put the IF can back, and then we can see if there is still something wrong or if this noise goes away when I have everything hooked back up. Okay, so I hooked the tone control board back up so that the amp is now not floating anymore. Let's see what we get now. That's already more silent. Okay, we're only at 80 volts. Let's go a bit higher. 179, 206, 226, and completely silent, but I do hear the volume control doing something, and I hear my cell phone. So the amp is working and we don't have any noise anymore. That's great. Haha. Amazing. This is 200 millivolts peak to peak on the pickup input, and I'm getting a really good tone. Okay, so since we changed the transistor in the amp, we do have to adjust the quiescent current again. So it's really simple. I have the procedure over here, but it's quite simple. So we're adjusting the... Wait, let me show you on the diagram. See, so we're gonna adjust the current here through the output transistor. That's the AD150 here. And they say here it should be 580 milliamps or 5.8 volts across here, this resistor, this 10 ohm resistor on the emitter. And we do that by adjusting this potentiometer over here, and we're going to measure here across this resistor. So see, that's quite simple. So here we have this 10 ohm resistor, and I'm measuring across it, and as you see we have 5.64 at the moment, and this is the potentiometer that we need to adjust. And let's see what we get. Okay, that's already in the right direction. It's a bit noisy, this potentiometer, but and it's also very sensitive, but that is really close already. Ideally we should let it warm up a bit. So you see, I'm almost spot on 5.8. I'm gonna let the radio sit here for a couple of minutes and see how this evolves, and then maybe adjust it a bit more, adjust it again when it warms up. So yeah, but minus 5.8 is basically exactly what we want here. So that's already good. So while I am in here and while the IF can is still out, I'm taking the opportunity to clean things up here a little, and I'm also cleaning the switchers here. So the sliding contacts, this one has already been done, and maybe I'm gonna do another one here on video just to show you how it's done. And they are quite easy to clean, but you do need to take the effort to take them apart, because don't think, yeah, they have a cap on top, so they are shielded, so they will be good. No, take them apart and clean them. Okay, so it's actually quite easy to do. Let me just take this one here, for example. You can simply put your screwdriver underneath here and pop the cover off. You don't need to remove the cap from the button on the front of the radio. You can just go underneath here on both sides, and normally you should be able to pop the entire switch off. It could be helpful if you press in the switch while doing this, I think. It's the transparent casing on top that comes off in its entirety. See? See, so there we have the pins for the switches, and here in this we have the, oh, come on, focus. Yeah, so here inside this plastic casing we have a small, yeah, it's basically a PCB which has the contacts and which shorts the pins, and you see they aren't clean. Okay, so now there are multiple ways of cleaning switches. Using cotton buds here is going to be difficult because, see, it just completely messes up your cotton buds. So you could use contact cleaner, for example. I have here some contact cleaner. You can use it on there sparingly, but the thing with contact cleaner is obviously you need something to slide there. Eh? So if I put in some contact cleaner on the pins here, just very sparingly, don't spray it all over the place. Come on. Okay. And just leave it soak in for a minute. Maybe we can use this to just slide and clean the pins. It's maybe not the worst idea. Be careful that you do this gently. Don't put too much pressure or come in the wrong angle, because you will bend these pins here. See, and this is also starting to clean up the contacts here on this PCB. Alternatively, you could also use a fiberglass pen and also gently, that cleans them up rather nicely, actually. Same thing here on the little board. There you can also use a fiberglass pen to clean these pads. And they do clean up rather well. So yeah, you see the difference? Yeah, they need to be cleaned. See? I can see that the tips of the contacts here are still a bit black, tarnished. So I'm gonna give it another small spritz of contact cleaner here. Okay. Now the contact cleaner that I'm using, they recommend that you wash it away afterwards with that they call it a universal cleaner, but I guess it's just isopropyl alcohol in a can or something similar. And that you can spray more liberally because it's really a washing fluid. It's like isopropyl alcohol a bit, so and then I clean off the excess here with some cotton buds, and you see what comes off. It's yuck. Ooh, be careful with these small wires here of the coils. See, so yeah. Okay, so as a last thing, I clean the cap, obviously, to make it look nice and shiny. And then the PCB here, see the contacts, they are also now, yeah, I also clean them again with some isopropyl alcohol, just to get the contact cleaner off. And then I treat them lightly with this one here. That's contact 61, and this is a sort of a lubricant and corrosion prevention for contacts, especially for sliding contacts. So what I do is I just put it on here ever so slightly. Yeah, that's too much already, but I just then let it run down. See that it goes to all the contacts. Same on this side. And I'm not in focus. See, I just let it come out of the can very gently. So this is now lubricated and protected against future corrosion. And then you can very simply put this back into the cap, the cap of the switch. And you just put it back, and you have to pay attention, of course, that this indent, it has to catch in the button of the switch. So you need to see that you position it correctly before you push it in completely. I think like this, more or less. Yeah, and then you just click it in, and that's that. And this one is cleaned. I already did this one, so I have 3 more to go. It takes quite a bit of time, but it's definitely worth it. Well, I don't think I've already shown the bottom side of the radio, so here you go. I am just soldering back now the IF can, or it's basically the entire IF section. And I've cleaned all the switches, so they should be good. It took a bit of time, but that's only a perception. Because if the switches are not as accessible as the ones on this radio, then you also spend a lot of time cleaning the switches, and you have to go back and forth all the time. And yeah, after a while, you maybe lose even more time than with a system like this. So there's that. Now I'm just gonna put back here the IF can, and then we're going to test the actual tuner part of the radio, which should be exciting as well. Okay, here we go. Let me put on the power on the dim bulb, and let's go to long wave. Okay, where I got 215 volts. I hear some hum, but is it receiving? I hear something. Very faint though. Maybe, wait, let me shut down my light bulb here. Yeah, makes a bit of a difference. But there's nothing much there. Oh. Yeah. Oh!
These things being scattered across the heavens have a fixed length of a month before they burn up in the atmosphere.
But its amplitude is quite low. But it's with the ferrite, it's a built-in ferrite antenna, so and it's about well, 5:30 in the evening here now, so I wouldn't expect much anyway. So, but this is great. At least it's receiving, but it's very silent in between stations. Maybe that's a feature. I don't know. Let's go to medium wave. I have the volume all the way up here now, and there is something coming through here, but not much. Shortwave. Nothing either. Ah. But I have the volume all the way up here now, so very faint. At least we don't have all the noise is gone. The noise from the leaky transistor, that is all gone. So yeah, FM won't have anything because I don't have an antenna connected. There we do have hum. Oh, wait, whoa! What just happened? Yeah, still nothing on the AM bands, but FM, wow! Just kicked into life suddenly. Don't know what happened here. This is without an antenna. There's no antenna connected to this thing at all for FM. This is amazing. How is this receiving? Jesus. Could have been the switch not making good contact in the beginning, but I do also have the automatic frequency control. Does that work? Yeah, it works. See, automatic frequency control is working if I just tune into a station. And then if I go outside the station slightly, wait. See, that's outside the station, and then if I push the AFC, it catches the station. Amazing. So yeah, that's working quite well. Now, why the AM bands are not working great, I don't really know. I would need to connect my mini whip and wait until it's dark to get a decent reception here on AM anyway, so I can't really judge that at the moment. Second problem is these connectors here for the antennas. They are quite weird. I don't have any... Yeah, they are DIN, I think. Yeah, the one in the cabinet for the FM, the dipole, they has a connector for this, but for AM I don't have a... So I need to make something to be able to connect this to my mini whip. Yeah, let's do that. First, what I also still need to do is attach here the amp PCB and the heatsink back to the cabinet. That'll be better to handle the radio. So first gonna do that, and then we'll see the quality further for the AM. See, and the tuning indicator is also working. Obviously, most of the stations are gonna have quite a low signal strength because I don't have an antenna connected, but it's quite impressive that even the stations with a very low signal strength, they come in very clearly. See.
Outdoor Swimming Belgium is daar blij om, maar heeft toch ook enkele bedenkingen.
Really nice. I mean, see, this is barely below 1 or above 1, and you can still listen to this. It's the sensitivity of the tuner on FM is fantastic. Really, really good.
Zo'n rechtse partij? Nee.
See, this is without AFC,
van de stemmen.
with
Denk via een
AFC.
tweede ronde in.
You can also see it here on the tuning indicator.
In Turkije heeft de commissie van internationale waarnemers meer uitleg gegeven over de
Nice.
verkiezingen van
Nice. Really nice. And I tested the treble and the bass, and they are also working fine. Now, I would like to point your attention here a bit to the volume pot, because it's not an original one. It has been replaced at some point, and you can clearly see that it's a bit longer than the other two. Remember, when we were disassembling the radio, we noticed that the button for the volume pot was sticking out a bit further than the other two, and that also the indent on the button, or the indication on the button, didn't align with the scale on the cabinet. So there was something wrong here, that's for sure. Well, the potentiometer that they used here, it's not an original one, and the indent here for the alignment of the button cap, it's not in the correct place. So they just filed it off in a random area, I guess. And I think also it's the wrong value on the schematic. It says 500K. I think this is a 300K volume pot. So I'm gonna replace it, and I found this one over here. This is a 500K logarithmic potentiometer. For volume, you typically want to have a logarithmic, not a linear pot. I had honestly a bit of a hard time finding an exact one with a 4mm shaft, which was 500 or 470K. I found a 500 one. Also logarithmic, and the shaft being long enough. All these requirements made it quite difficult to find one, but in the end I did find one, and I'm gonna replace that one with this guy. And obviously I will have to file off an indent here as well, for the knob to fit on, because the knob has a D-shaped hole. So yeah, I think it's a good idea to replace this guy in there. Yeah, but first of all, we need to get this one out, obviously. Yeah, I made a small mistake. I ordered a potentiometer which has 3 lugs, but I didn't notice that this one on here also needs a center tap. So the one that I ordered, I couldn't use it. So I managed to repurpose the one that was in there. I completely took it out, and I noticed that it was actually a 500K logarithmic pot, so I just must have measured it wrong. So that was fine, but what I did is I mounted it back a bit backwards. I put a washer in between to have it shift a bit backwards, and then I filed off the flat part on the shaft here a bit further down, so that the button can slide in further down. And now all 3 buttons, they are nice and equal on the same distance. And also I reoriented the pot so that the travel of the button now is okay, and it matches the scale on the dial. But then it took quite a bit of time, because I had to completely take it out, and I had to isolate the pins of the potentiometer, because otherwise they would have been touching the chassis here in the back. And then I had to reattach everything, and in the process there is this 47 picofarad capacitor over here. That one broke off really at the edge of the capacitor, so that one had to be replaced, and I didn't have that in stock. So I found one on some old PCB board that I had laying around. There was one located over here somewhere. I was very lucky. So that one I could solder it off, and I could salvage it, and I'm now using it here in the circuit. And yeah, it doesn't look that pretty, but it's working, and it's now a bit easier also to yeah, I had basically no other choice because the contacts of the potentiometer, they are here now all the way at the back, and it would be quite difficult to reach them, so I extended them with some wires, and then I soldered everything to these wires. And I checked, and I think it should be fine in terms of isolation. I don't think any of the wires are touching each other here. So yeah, and I also cleaned the volume pot, obviously. So now it's working fine. That took a lot of time, but okay. Okay, so I think I'm gonna leave it at that for this video. I guess it will be already quite long enough. But I'm sorry that it took so long to put out a new video, but at least I did manage to make some progress, so that's nice. What are the things that still now need to be done? Let me first give you a demo on how it sounds, and then you'll immediately notice. So let me just... Can you hear this? This distortion on FM. I think that's it's something wrong with the detector. I think the detector is misaligned. Well, I was wrong. I've got now my other tuner here hooked up to the pickup input, and I still get the distortion. See? So there is something still wrong in the amp or something. I don't know. Same thing if I switch to the signal from the signal generator. This is a 70 Hertz signal, 78 Hertz. See, that is not normal. And if I go higher in frequency, then it goes away. So if I go above 80 Hertz, see, this is 80, 81, and then it starts smoothing out. See, this is 100, 200. Ah, there is also a bit over there. So it has something to do with output power, I think. As soon as you go above a certain power and output, that the amp starts clipping. Okay, I've got here my signal tracer hooked up that I restored recently, and let me show you something. So if I trace the signal at the base of the AC122 that I swapped earlier in the video, so the base, that's this one. See, I have the sound quite okay, but if I measure it on the collector, which is the base towards the next transistor, that's this one. See? Okay, it's clearly distorted there. And this is the bass. So I don't know. Okay, I think it's happening here around this transistor that we get a distortion, but I don't know exactly why or how this distortion is happening here. Yeah, I'll have to dig a bit deeper in there. Yeah. On AM there is almost no reception at all. I can show you, but it doesn't really make a lot of sense. It's very, very faint, and even with the mini whip, it's better, but not great. You really have to put up the volume all the way. So I think it also needs a yeah, we'll see. I think it needs an alignment. The alignment might fix these issues. Let's see. I remember that the previous owner told me when he sold the radio that it might need a bit of alignment. So I think he must have fiddled with something, and maybe because the noisy transistor maybe was mistakenly identified as some kind of bad reception or something wrong in the tuner, and maybe you started fiddling with the alignment, trying to get that distortion out, but obviously he didn't manage to do that. So I don't know how misaligned the radio is. We'll have to see. So that's what I'm gonna do probably in the next video, is to do an alignment of the AM and the FM. And also then obviously still the cabinet itself. There is not much work on the cabinet, so it's just a matter of cleaning and touching up a bit here and there. And that's about it. So then would like to thank you for watching if you're still awake. And I hope that you won't have to wait that long again for the next video. So thanks for watching. If you like my content, don't forget to subscribe to the channel, and then I'll see you next time. Take care. Bye bye.